Today's lesson is going to focus on the second type of chemical reaction, which are decomposition reactions. Decomposition reactions are probably the easiest to identify, as they are always going to start with one reactant. So always, you're going to have one reactant, and that reactant is going to break down into two or more products. And those products could be a combination of an element and a compound. It could be two elements. It could be two compounds. It all depends on the starting reactant molecule. Similar to synthesis reactions, we are now going to learn some detailed decomposition reactions. And there are 6 of them altogether. There are quite a few. Some of them are exact opposites of the synthesis reactions that we learned, and a couple of them will be new and a bit unique. So the first example of a decomposition reaction are when you have a binary compound and it breaks down or decomposes into the two elements that form it. So here's an example of mercury 2 oxide. And so if we start with mercury 2 oxide, we know that it will break down into its two elements of mercury, which is a liquid at room temperature. It's the only metal that is a liquid. And we know it's going to break down into oxygen. And we remember that oxygen is a diatomic gas. Okay, so again, we can put those states in as we go. And we just simply balance after that. So you have 2 oxygens. You need to come over to your reactant side. Give yourself 2 oxygens there. You just changed your mercuries, so adjust the coefficient. The other example is sodium chloride decomposing. Now that says a liquid, and that should say a solid, okay, because that is a solid at room temperature. And when we break that down, we break it down into sodium, which is a solid at room temperature, and not a diatomic gas. I will sometimes see students write Na2. Or up above, mercury 2 after it. And you have to recall that the only diatomics elements that exist are those Hofbrinkel elements. So chlorine is one of them. It would be Cl2 in its standard state. And then from there we balance. And so we put a 2 in front of sodium chloride and we put a 2 in front of sodium. Another type of decomposition reaction that will be new to you is metallic carbonates. So this is when we have some sort of metal. Okay, we have an example of calcium carbonate in the example listed here. It could be sodium carbonate. It could be iron 2 carbonate. It could be any metal with a carbonate. When heated, which implies that we would have a little triangle above, will form the metallic oxide and CO2. So you have to kind of memorize this. If our metal in this example is calcium, that means I'm going to form that metal oxide. So calcium oxide. And when we come up with those formulas, just double check the charges on everybody. You always have to check the charges and come up with a new formula. Both of them have charges of 2. And this is going to be a solid state. All ionics are solid unless they're dissolved in water, which is not happening here. And then the other compound coming off is carbon dioxide gas. So we simply double check, is everything balanced? And it is. And so we're good to move on. Another type of decomposition reaction is a metallic chlorate. So previously we saw metallic carbonate. Now this could be any metal with a chlorate polyatomic. And it says there that when we heat it, it decomposes into the metal chloride and oxygen gas. So in our example, we have potassium chlorate. We are going to heat it. So that means there'd be a triangle above the arrow. And we need to form the metal chloride. So we take the metal, which is potassium, and we combine it with a chlorine. Double check the charges. Each of them have charges of 1. Okay, so again, you can look on the periodic table quickly to tell you that. And so crisscross rule brings 1s down. We are still going to be in the solid state because it is an ionic compound. And then we're forming oxygen. And we know oxygen is one of our diatomics. and we put the state in for gas. Look along, you need to balance this. So here's an example of our oxygens having an odd and then an even amount. And the trick there when we have an odd even is always multiply each of those elements by the opposite value. So if I have 3 oxygens here, I'm going to multiply by 2, and then I come over to this side with the 2 oxygens and I multiply by 3. So it's just the opposite subscript. Now I have 6 of each. I do not have an equal number of potassiums and chlorines, so I balance with a 2. Another type of decomposition is the decomposition of oxyacids. So in our synthesis note, we saw the creation of oxyacids. This is just the opposite. So we're going to decompose our oxyacid into a non-metal oxide and water. And remember here that these are like a covalent molecule, so all atoms must add up. Okay, so there's no ions here for you to do crisscross rule. So what I would do is I would look at that and say, okay, I got an oxyacid. I know I've got to take water out of there. So I'm going to do a liquid. Ooh, and this should have a state of AQ beside it. And what will be left over is my non-metal oxide. So I've already accounted for 1 oxygen to come out of that oxyacid formula. So what would be left over would be SO3, which would be a gas. And then all of our atoms add up on either side. The 5th type of decomposition reaction is the decomposition of bases. So bases are metal hydroxides, and if we heat those up, we will form a metal oxide and water. So let's pull the metal oxide out. My metal is calcium, so I'm going to take calcium and combine it with oxygen. Double check the charges. In this case, each of them have charges of 2. This is going to be a solid because ionics are solid at room temperature unless water is around. And then we're going to bring off or derive off a water molecule. So water will be present with a state of liquid. We're just going to change this, a couple of typos on our slide. So that calcium hydroxide should be AQ initially. And then we just double check if we need to balance anything. And at a quick glance, I do not. All my oxygens and my hydrogens are balanced. Same with my calciums. And then the last kind of decomposition reaction is with our hydrates. So we saw hydrates in nomenclature. And if we heated up a hydrate molecule, all that you do is you drive off the water molecules. So as it says, it decomposes into their actual compound, which in this case would be CuSO4, and this would be a solid. And then you have however many water molecules are attached, which in this case are 5 waters. So there you go, 6 different kinds of decomposition reactions for you to learn about.